Okay, now see here, I want to just briefly tell you what is shear force and what is bending moment. Not the definition, but how we plot it while solving the problems. Okay, just briefly, we'll look into the detailed concept when we are going for problems. But for understanding sign conventions, what I'm going to do is I'm going to briefly tell you what is shear force or what is bending moment. Suppose we all know that shear force is going to vary from one cross section to other cross section. Suppose I want to find what is the shear force at this cross section. If I want to find what is shear force at this cross section, what I'm going to do is I'm going to add all the forces either towards the right side of this section or towards the left side of this section. Suppose I want to find what is shear force at this section. What I'll do is if I consider right side, then there are two forces. One is W by 2 in upward direction and other is W in downward direction. If I add both the forces, then what I'll get is I'll get what is the shear force at this cross section. I can go from right side also, or I can start from left side also. If I start from left side, there is only one force, that is W by 2. Okay, if I consider this section, there is only one force, that is W by 2. So this W by 2 will be equal to whatever force I am getting after adding these two forces. So what I can say is if I come from right side or if I come from left side, I will get the shear force at a particular cross section. I can either come from right side also, I can come from left side also. For example, if you look at this cross section, okay, towards the right side there are two forces. If I consider downward as positive and upward as negative, see, W minus W by 2 will be plus W by 2 because it is downward. Okay, similarly if I consider from left side, there is only W by 2. Here also we got W by 2 and here also we are getting W by 2. Don't worry about sign conventions now itself. After explaining the sign conventions, then you will get the idea. So one thing you need to understand here is if I want shear force at any cross section, I need to add all the forces either from right or either from left. You can choose any method. Okay, then similarly if I want to find what is bending moment at any particular cross section, suppose I want to find what is bending moment at this cross section, then what I'm going to do is I'm going to add all the bending moments either from right or from left. Suppose I am considering this cross section at this point. What I'll do is if I come from right side, then there are two forces, this W by 2 into whatever the length is there from this section to this W by 2, that length into this force, and again plus or minus this W into whatever the perpendicular distance is there up to this section. When I add the two moments, I'll get the bending moment at particular cross section. You can come from right or you can come from left also. In left side there is only one force, this force into whatever the perpendicular distance is there from this section to this force, that we consider will get bending moment. You come from left side or right side, you will get the same value. Okay, this is how we plot bending moment or shear force at particular cross section. For shear force we'll consider summation of forces, and for bending moment we'll consider summation of bending moments. But when we are considering these forces or moments, there are particular sign conventions which we need to follow. So what are the sign conventions which we need to follow for shear force diagram or for bending moment diagram are shown here. Okay, first for shear force diagram, if this is a beam and if I want to find what is the shear force at this cross section, if I am coming from right side, okay, and if the force is in downward direction, take it as positive. If I am coming from left side, if the force is in upward direction, then take it as positive, because if I want to find shear force at this cross section, I can come from right side or I can come from left side. Okay, from right side if you come, if downward is a force, then positive, and from if you come from left side, if upward is a force, then it is positive. Okay, for positive shear force, the beam will bend somewhat like this. Okay, when I apply shear force, there will not be increase in length, but there will be change in shape. Okay, so if the shape is if the bend shape is like this, then it is considered as positive shear. Then negative shear, exactly opposite to this. If this is a beam and this is a cross section, if you are coming from right side and if the force is in upward direction, take it as negative. If you are coming from left side, if the force is in downward direction, take it as negative. How is the deformed shape? The deformed shape looks somewhat like this. Okay, so this is for negative shear force. Then similarly for bending moment diagram, we are having sign conventions for both positive and negative. See, bending moment is represented as M, where M is nothing but force into perpendicular distance. Suppose this is a beam. Okay, this is a beam and this is a cross section where I want to find bending moment. If I am coming from right side and if the after applying force, suppose if I am applying a force in upward direction, what that force will do is it will bend the beam like this. Okay, it will bend the beam like this. You can see here, after applying a force in upward direction, the beam will be bent like this and moment is represented like this. Okay, so in this direction, if the bending moment is applied, then it is taken as positive. And if you are coming from left side, again, if the beam is trying to lift, if the moment is trying to lift the beam in upward direction, then it is taken as positive. In general, if the moments are causing a smiley moment, okay, after bending, you can see here it looks somewhat like a smiley face. Or you can say if the moment is lifting the beam upward, either you come from right side or from left side, if the moment is lifting the beam upward, then such a moment is taken as positive, and this shape is called as sagging moment. This is called as sagging moment. Exactly opposite to this, we are having sign conventions of negative bending moment. This is a cross section where I want to find bending moment. If the moment is applied in this direction from right, then it will bend the beam in downward direction. And then if I am applying bending moment from this side, then it will bend the beam in downward direction. Okay, if the bending moment is causing the beam to bend in downward direction, then we take it as negative bending moment. This is hogging. This type of bending is called as hogging. Take few moments and look at the sign conventions carefully, because while solving these problems we'll be using these sign conventions. Once you are perfect with sign convention, then we can go on to solving problems. Okay, once again remember, only positive bending moment, exactly opposite to positive will be negative. So first observe the positive shear force direction or positive bending moment direction, then you can start with the problems. Now before starting problems, if you look at some of the shear force diagram and bending moment diagram for different standard cases, this is for cantilever subjected to point, this is for cantilever beam subjected to UDL, this is for cantilever beam subjected to UVL. Upper diagram is shear force diagram and the bottom diagram is bending moment diagram. Now if you look at this bending moment diagram, it is having a linear curve. But similarly, if you look at the bending moment diagram for UDL, it is having a parabolic curve. Similarly, if you look at bending moment diagram for UVL, it is having a cubic curve. So how to decide whether the curve should be linear or parabolic or cubic? For that we need to understand some basic concept. First we will look at those basic concepts and then we'll move on to how to plot the shear force diagram and bending moment diagram. Okay, what are the concepts on which we are going to decide whether the curve will be linear or parabolic or cubic? To understand that, first consider this graph. There is a y along y-axis and along x-axis we'll consider x. That means y is a function of x. When I change the value of x, the value of y is also going to change. And suppose I am getting a straight line curve. Straight line curve is having a equation, or equation for straight line curve is, or linear you can consider, is given by y is equal to ax plus b, wherein a and b are constants. They are not going to change. Only parameter which is going to change is x. When I change the value of x, then obviously y is going to change. Now how to decide whether the curve is linear or parabolic is, look at the maximum power of the variable. what is the variable here? X is the variable. What is the maximum power of X? It is 1. When the maximum power of variable is 1, then the curve will always be linear. Remember that. Okay. Now apart from that, look at the slope. Slope of this curve is given by, see, if I consider 2 points, one point is here and second point is here. From this to this point along y-axis it is dy, and from this point to again this point along the x-axis it is dx. If I want to find slope of this curve, then it is given by dy by dx. So remember this also. Then how to decide whether the curve is parabolic? Parabolic curve in the sense it is slightly curved. The curve equation is given by, parabolic equation is given by y is equal to ax square plus bx plus c, where a, b and c are constants. X is the variable. As x changes, y is also going to change. But look at the maximum power of the x. Maximum power of the x is 2. Here it is 1, but from both of them maximum is 2. Whenever maximum power is 2, then the curve will be parabolic. Remember this. Okay. Then look at this graph. The curve is cubic. Cubic in the sense the curve is slightly more curvier than the parabolic. You can see here it is slightly less curved, it is more curved. Okay, this represents cubic curve. What is cubic curve? It is represented by equation y is equal to ax cube plus bx square plus cx plus d. Again, a, b, c and d are constants which are not going to change, but x may change. When x changes, there is change in y. What is the maximum power of the x? It is 3. 3 in the sense cubic. Okay, whenever in any equation which we are going to discuss in our further classes, if that equation is having maximum power of variable as 3, then the curve we are going to get is cubic. If maximum power of variable is 2, then the curve which we are going to get is parabolic. If maximum power is 1, then the curve will be straight line. Okay, you need to remember this. Only then you will understand the concept. Now come back to slope. Like I said, slope is given by dy by dx. If we consider x-axis, okay, if we consider any curve on the x-axis, this dark portion, then if we consider slope of this curve, it is dy by dx again. But look at this. Is there any dy? Is there any direct distance in y direction? See, here we consider dy is distance in y direction. For this curve, there is no distance in y direction. That means dy is 0. 0 by dx will become 0 by anything is 0. So dy by dx will become 0. That means slope is 0. So for horizontal curve, slope will be 0. Then if you consider vertical curve, again slope is given by dy by dx. Okay, there is dy in the sense distance along y direction, but is there any distance in x direction? No. So dx will become 0. dy by 0 or anything by 0 will become infinite. That means slope for vertical curve is infinite. Slope for horizontal curve is 0. Slope for vertical curve is infinite. That means if I consider any curve, okay, as I move, as the curve becomes close to vertical curve, the slope goes on increasing. That means here horizontal slope is 0. If I consider one curve like this, it will be having some slope. If I consider second curve like this, it will be having more slope compared to the previous slope. As I move towards the y-axis, the slope of the curve is going to increase. Okay, this is about slope. Then again consider a graph of y-axis versus x-axis. Suppose I am getting a random curve like this. Okay, this is also important. When I am getting a random curve like this, look at the maximum point of the curve. That is maximum value. This is the maximum value. If I want slope at this point, what I am going to do is I am going to draw a tangent. Suppose I want slope at this point, I will draw the tangent. Suppose I want slope at this point, I will draw the tangent at that point. Similarly, if I want slope at this point, I'll draw the tangent at this point. It is a horizontal line. For horizontal line, we know that slope is equal to 0. So for maximum point of the curve, slope is always equal to 0. Now come back to minimum point. This is the minimum point in the curve. Again, at the minimum point, you can see that if I want slope at this point, I am going to draw a tangent. That tangent is again horizontal. So for horizontal line, again the slope is 0. So remember this point. For maximum point also in any curve, slope will be 0, and for minimum point also in any curve, slope will be 0. With this basic knowledge, we can start construction of shear force diagram and bending moment diagram for some standard cases, and then we will move on to problems. Okay, this is it for this lecture.